Okay, good morning.
Good morning.
Only 15 of us today. All right, so we're going to talk about the project, and this is what we're going to do every Friday. So these are helpful lectures because I give you a lot of information about my expectations, and you guys get to ask questions about what's going to work and what's not going to work. And so we'll go through some details as we go through. Here we are on January 29, project discussion, primarily about picking a topic. And then you have a week. Next Friday is the deliverable for the your topic proposal. And it's short. It's a one-pager. So let's talk about that. And I'll put out, you know, I put out hopefully every Friday the week ahead announcements. Make sure you read those. They give you all the due dates and they give you some interesting information. Also, I put an announcement out last night about a Lockheed Martin scholarship. It's targeted for freshmen and sophomores. So that's a good group, you know, the right range for most people in this class. So take a look at that and see if that's something you want to apply to. There's a link on the flyer to get more information. That's pretty much all the information I have. 10,000 a year though, not bad. All right, next week in terms of our topics, we're going to move into selection and repetition, which is if then else structures, and for loops and while loops inside of Java. We don't do recursion until the last part of the semester. Okay, so what about this project? I've given you this document. It's listed as an assignment, but there's no points, right? It's P0. And so it's informational only. So there's no activity for you to do here in P0 other than read through this and understand what the goals of the project is. The idea is you will, as an individual, not as a team, as an individual, pick some kind of a topic and then write software to produce a product based on that topic. And I have 4 main requirements, and this is critical. First of all, you have to use a GUI. So all user interaction has to occur through a GUI. That's a graphical user interface. And we have about 2 weeks of discussion and examples about how to create graphical user interfaces. About 4 weeks out from now. This GUI must be created using JavaFX. Now, Java had initially when it came out, the graphics package they used was called AWT, Abstract Windows Toolkit. That's really old stuff. So I will not accept anything for using AWT. Nobody liked it. And so they revamped it and they came up with something called Java Swing. And nobody liked it. So now a few years ago, they came out with something called JavaFX. So make sure that when you are bringing in, creating your GUI, that you're using only JavaFX items. Make sure when you're looking for help online and you Google, you're Googling JavaFX. Otherwise, you're going to get a bunch of Swing stuff. I still get 1 or 2 people a year that start out with Swing, and I try to catch them early and say, no, that's not going to work. You have to use JavaFX. There's a more advanced toolkit that can be used with JavaFX called FXML. I don't like that either. So I'm being pretty rigid here, but also being very clear. Use JavaFX. The second major requirement is you have to have file I/O. Now this is a fairly trivial requirement to meet. Any simple writing to a file and then reading from a file will work. A lot of you guys like to do games. And guess what? In a game, you get a score and you want to keep the high score or the top 3 high scores. There's your file I/O. Write the scores out to the file And then if someone wants to look at them, you read the high scores in from the file, and there's your file IO. Others of you are going to do simulations. Some people like to do like genetic algorithms or neural nets or something like that. And what you can do with that is take the training data that you do for while you're in the machine learning process, and then write out progress or write out the final situation. And then when you want to use that learned machine behavior, you read it back in from the file. Some of you might do some simulations or tests. I had people that did last semester typing tests. You know, it was measuring how fast you were using key clicks and how many errors you made. Well, that would be a test result that you could save to a file, and then you could read that file in to show someone how they did on the last test. So this is a fairly easy requirement to make. JavaFX does work. I can't remember when it came in. I'm pretty sure it works with Java 8. I think that's when they introduced it, but it's been so long and they've gone through a couple of iterations that I can't remember. And then Oracle did some weird stuff with FX where they kept it as a separate package. So it's gone through a couple of iterations, but I believe that's correct. Third requirement, you have to have exception handling. Now, what's exception handling? We'll talk about this in about 5 weeks or 4 weeks in detail, but exception handling is basically this. When your code gets an execution error and crashes, you have the ability in Java and in most modern programming languages to do what's called handling the error. So rather than have your code crash, you write other code, alternate code that gets executed when the error occurs. So if the error occurs, you run some other code and your program doesn't crash, and you somehow manage or handle the problem. This is also an easy requirement to meet. Almost everyone will have a situation where you have to have the user type in something in a text field. They have to type in their name, or they have to type in a file name or something like that. And anytime you give the user free-form text input like that, where they can type anything they want, you can use exception handling. For example, let's say you need them to input a number and they put in a string. That's going to cause an exception. So you can write exception handling to catch that and then tell the user that they made a mistake, tell them how to fix it, and your program doesn't crash. So this is another fairly easy one to get. Items 1, you know, having a GUI, you have to have it by default. Item 2 is an easy one to get. Simple file IO. Item 3 is an easy one to get. Exception handling somewhere in your program. And item 4 is that you have to use inheritance. So we're trying to teach the object-oriented paradigm. Inheritance is a critical feature of the object-oriented paradigm, and so you have to have inheritance in your software. Now, there are a couple of restrictions to these things. So on item 3, you can't use exception handling with your file IO. And the reason is a lot of file IO routines basically require it. So I need you to do something in addition, you know, above and beyond what you might have put in for your file IO. And then for the inheritance cannot be related to the GUI. And what we'll see with JavaFX is you have to use inheritance to create your GUIs using JavaFX. And the reason is Java program, the Java language, gives you some basic graphical objects, and you always extend them, you know, use inheritance to personalize them to your application. That's a given. So I need you to do inheritance somewhere else. And we can talk about where that is. For example, in the sheep-dog game, how did we use inheritance? I have a dog, I have a sheep. I created a generic animal. I extended it to the dog. I extended it to the sheep. Boom, there's my inheritance. People tend to do you know, run away from the zombie games. You have a generic character, extend it once to the non-zombie characters, extend it again to the zombie characters. There's your inheritance. It's just making sure that you're using a critical feature of object-oriented paradigm in your software. Now, if you meet those 4 requirements, what do you get? Nothing. These are bare bones, minimal requirements. If you don't have them, what do you lose? 50 points per. So I've had students in the past that have turned in things that did not have file IO, did not have exception handling. I knock 100 points off their project right off the bat. It doesn't happen often, fortunately. The reason I'm strict about this is, again, these are minimal requirements. If you're an industry and you miss a bare bones minimal requirement for your customer, they're not going to pay you, period. They want to pay for a product that meets all the requirements, including the bare bones minimum ones. Same thing, like this scholarship application. That scholarship application is almost certainly going to have a form that you have to fill out, and it's going to have formats, and you have to submit files in PDF or docx or something like that. And if you submit a JPEG, they're not even going to look at it. Boom, you don't get the scholarship. So these are minimal requirements. And all of these have a lot of discussion and examples as we go through the semester, and labs that talk specifically to these things. Okay, questions about those basic requirements? Okay, the formats, I give you the formats. I'm going to give you template documents and you fill them out. If you are using some other format, I have people just type stuff up on pieces of paper or hand draw things on pieces of paper. Then if you don't follow the format, the grade is 0. And again, this is getting you used to the idea that when you have a requirement, you shall follow the requirement. We submit proposals for research grants fairly often, and that's one of the things professors do in a university. And they tell you the format, this you have to have, for everybody who's working on the project, you need a biography, and it can be no more than 2 pages long per person. If you're going to do the technical description of your work, it has to be 10 pages and no more. And it has to be, 12-point Times New Roman font. And if you turn in something that's, longer than 10 pages, they don't even look at it. Just throw it in the trash. So when we have requirements about formatting, it's a big deal. So what I'll have, again, it's actually easier for you because I'm giving you the formats. You don't have to guess as to how to make a good report. I'm telling you how to make a good report for this class. Topics, it's up to you. I do not want to impose a topic on you. I would suggest, if you can't think of anything, I'm happy to suggest stuff, and I've got some suggestions, but I don't want to impose a topic on you. I want you to be excited about your project. I want you to do something that has personal value to you. It can be a game. Games are really popular. It can be a personal piece of software that you need for something in your life or something in a club. I've had students try to build scheduling software, which I think is a great idea, remarkably difficult, but they try to use scheduling software to help manage their course load, manage their assignments. So you can use something that's useful, something that's not useful. I just want it to be something that you're interested in. And what I really hope is that after the semester, it's software that you take with you and you keep improving and you keep using and you keep messing around with. I really don't like it when in a school system where you have a software assignment and after the assignment's done, nobody ever sees that software again. Like the assignments that we do for the homeworks, that's kind of normal. That happens that way. So you're given a problem. Hey, write a piece of software to solve this problem. Okay, did it, and then you never see that software again. And I'd much rather, since you're going to spend a lot of effort on this, hopefully spend a lot of effort on this, have software that after the semester you can still use, enjoy, modify, expand. There are Some people will propose something that's way too big. And so that's fine. What I'll do is I'll say, okay, let's scale it down so it fits within the semester. You meet the semester goals, you get an A in the class, and then you take this skeletal structure that you have and you can spend the next 5 years filling it out. 2 years ago, I had someone who was doing a car maintenance software. And you can imagine just having all the data input is a problem. How many different kinds of cars are there and how many different things can be fixed on all those cars? How many different part numbers are you dealing with? And so what we agreed was he would get the basics down there. He would make it work for a couple of parts for a couple of different kinds of cars. And then he can spend the rest of his life filling out data. And that worked out really well. A lot of people do games. I have had to ban a lot of games. Battleship, Tetris, Othello, chess, blackjack, poker of any form. Poker games are always awful. Blackjack, I've had dozens of blackjack programs. They were all hideous except for one, which was really done well. And it's because it wasn't about playing blackjack. It was about studying blackjack betting strategies where the computer played itself like 1,000,000 times. And then you looked at the statistics. So I banned those things. The reason I had to ban a lot of these is not just that the software wasn't that good or the projects ended up not being that good, but I was getting, quite frankly, a lot of plagiarism. So people were going to do blackjack or Tetris, and then I would find the code online from 2015, and that was a problem. So I would like to remove that temptation from people because sometimes people panic at the end of the semester and make bad choices. I'd like to remove that temptation from you and also steer you towards maybe more creative uses of your time and talent. So you may not have been thinking about what topics you want. You've got a week. I've got some examples. My examples tend not to be very popular, but that's okay. I don't feel insulted. I just have a different view of software. And then we have these deliverables. So by a deliverable, that's something you turn in for a grade. P1 through P7. P1 is the proposal. Once you get a proposal done, then you do P2, which is your functional description. So now the proposal is just a short, hey, this is what I want this thing to do. And then the second one, the P2, is a more in-depth one. And again, before you turn that in, I'm going to have a lecture on that, maybe two. And I have writing examples that we can go through. The thing about the P2, I'm saying it's a functional description. It should be as detailed as possible. So some people want to do, like last semester, we had some people that did, I have a spaceship that I want to go from Earth to another planet, and I want to calculate the trajectory. And so I have to have the motion of all the planets, I have to have all the gravitational effects. And so the requirement for something like that is you have to describe in your software, ultimately you're going to have a mathematical formula for the motion of Earth around the sun and the motion of Mars around the sun. That formula should be in the P2. In other words, you don't wait to figure it out until you're doing the software. You try to get as clear an idea right down to the formulas you're going to use in the description ahead of time. And this is a theme I'm going to be pushing and pushing and pushing throughout the semester. You don't just run off and start coding. That's going to be a disaster. You think about this stuff ahead of time to the degree that you can and get an idea of the structure that you're going to make the program and what information you need and what formulas you want, that kind of thing. So in the P2 deliverable, you're not talking about the software so much, you're talking about the intrinsic problem itself. So that person, what I was looking for in their P2 was fuel burn rate equations. Energy, converting fuel, which is potential energy, to motion, which is kinetic energy. Those equations exist. Now that person wanted to do that project, right? So that person had an interest in those things. And so that person I knew had access to that information. The hard job for me was to try to get them to write it down. Similarly, if you're going to do, let's do sheep-sheepdog game. In my head, I want to have, okay, I want the sheep to run away from the sheepdog. I can lay that out before I do any software, right? I can lay that out in terms of design. Okay, I always want them to run tangentially away from the dog, right? So if here's the dog and here's the sheep and I draw a circle, I can draw, it's not tangential. It's always orthogonal to the tangential. It's basically, I take that radius, that's now a vector, and the sheep runs along that vector. That's math, right? I can put that down in my description. I encourage, and almost everybody will need some kind of reference material. So I'm encouraging and requiring when it's needed, references and citations. So for example, sheep-sheepdog game. Maybe the way I should start that out is describing how a real sheepdog trial runs. Well, there's organizations for that. There's rules for that. I don't have to list all the rules, but I can take a reference to that. This is, and give a general idea. This is how a typical sheepdog trial runs. You're in an area this big, there's 3 sheep, there's a pen, the dog has a minute and a half to get them in the pen or whatever. And so I can lay those rules out, but then I have to show where I got them, right? Anytime you state a fact, you have to show where you got it. So then I would have a reference to I don't know the name of the sheepdog group, but their rule book, and then I would cite it up in the body of the document. It's a real document. People will do, platformer games seem to be really popular. I'm going to do a platformer game similar to, I don't know any games, similar to game X. Uh-oh, you just named game X. You got a trademark issue, a copyright issue, and you've got a citation issue. Because that game exists in the real world, you have to give credit to them, and you have to show where that game came from. Now, usually that does not mean the site where the game is. Usually it's like an article in Wired or something that's a review of the game. Something that's not a website. So the P2 idea is try to get an idea, not of your software yet, but of the problem you're trying to solve. In P3, now you're doing software design. Oh, okay, so now in P2, I say, here's the problem that I'm trying to solve. And in P3, you're taking your first cut at, okay, here's how I think my software is going to look to solve it. And so what you do here is you're developing your class diagrams, much like we did with the sheep-sheepdog game. Remember those square boxes with the generic animal, the dog extends the generic animal, the sheep extends the generic animal. I've got terrain over here. You're going to create a diagram with these boxes. And what you've done by P3 is you've decided on, okay, now I know what problem I'm trying to solve because I did P2. Now I think I have a software design. So here's the classes I need. Here's the attributes they have to have. Here's the methods that they have to have. That doesn't mean you've solved the problem of how the methods work yet necessarily, but at least you know that you need this object to do this action, therefore I need a method for it. It doesn't mean I've figured out yet how to do it, but it means that I know that I'm going to have to do that later. So notice the first is a proposal, the second is a problem description, the first is a software description, which by the way is going to be wrong. You're going to change it as you go actually implement your software, and that's fine. The idea is to have a plan. Those 3 deliverables, no code, no coding, no software. I'm going to, again, push you and push you and push you to not write code until you're ready. And that gets us, let's look at the schedule here. That gets us all the way to, let's see, P3 is here, 19 March. So we're already towards the end of March. And I'm telling you, don't write code. And then what happens after that? Now it's code, 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 code. The reason you have to do it this way is this is hopefully a fairly sophisticated piece of software. And if you just run in there, put on the goggles and the silk scarf and start typing, you're going to type yourself into a disaster. And it is, quite frankly, difficult for me to convince all of you that the upfront work that you're doing in P2 and P3 is worth your time. So I'm going to have, if this semester holds like any other semester, somewhere around 5 to 10 individuals who didn't put a lot of work in on P2 and P3, and then when they're coding, they're going to come to me and the lab tutors and say, this thing's a mess. I don't know what to do. By the way, this design in P3 is written down in a diagram called a UML diagram. And again, we'll talk a lot about what that is, a UML diagram. And if you come to help from me or from anyone else, the first thing they'll ask you is, I need to see your UML diagram. So if you don't have that, you haven't thought that through, then right away, we can't help you because we don't know what you're trying to do. That's how critical the design is. In fact, I had a student just the other day, last semester, that was, I'm having trouble with my code, Here's some of my classes, he sent me some code. And I said, I need to see your UML diagram. I need to see your P3 deliverable. And they sent that to me. And I said, this is not sufficient. You don't have a design yet. So let's work on that. Let's not work on code. Let's work on organizing this thing before we can work on code. So you have to know what you're doing before you start coding. The whole point of this is once you get to the coding, if you've done it right up front, the coding is trivial. Now it's annoying because you're going to have typos and errors and things aren't going to work exactly as you wanted to, but overall it's trivial. It's not one of these, oh my God, I don't know what I'm doing and there's a lot of code and it's a big mess. We get rid of that problem, right? We try to get rid of that problem. And we do it using very specific techniques. If you look at, let's talk about sprints just for a second. So the big hot way to develop software in industry these days is called agile, is a generic term. And the more specific form that's pretty hot is called Agile Scrum. So I'm going to introduce you to the Agile process as part of your project development. The Agile process is a team-based process, and you are an individual, so parts of it won't really apply, but parts of it do apply, and the parts that apply are how you're going to plan things out. So I've got these things in P2 called user stories. That's an Agile artifact. It's a one-liner description of a specific piece of functionality you want your software to do. And then what I'm going to have you do when you write your code is rank your user stories from most important to least important. And then you work on them in that order. So you're never working on, quote, the code. You're working on a little tiny slice of the code, a manageable, understandable part of the code. And once you get that done, you pick the next user story, you work on another little piece of code. And you keep doing that and filling out your code bit by bit by bit until by the end of the semester, the whole thing works. When it works really well and people are sold on the idea. Again, sometimes, everyone has issues, schedule issues that you didn't expect are going to crop up, or, sickness in the time of a pandemic, these kinds of things. Obviously, these hurt any process. But if you follow this, right, if you just trust me, right, trust me and follow this process, it actually works well. It makes your programming easier. It makes your programming clearer because you have a very small problem in front of you at any point in time. And you don't get overwhelmed with, oh my God, I got to do this and I got to do this and I got to do this and I got to do this. You've already laid it out. I have to do that first and don't worry about anything else. Next, don't worry about anything else. And then when you move to SC300, you'll do the same process in a team environment. So this is giving you good practice to get used to the terminology of the Agile process. So when you go to SC300, you've already got some familiarity with it. I'm giving effort estimate here. And now, I think they're fairly good. However, whenever we're talking about software, then estimates can vary wildly. So last semester, I asked for feedback from students. How long did you work on this? How long did you work on this? And I'm asking that again this semester. It's extra credit. It's the easiest extra credit you're going to get. So for some of your homeworks and for your project deliverables, beginning with homework 1, when the day that you turn in homework 1, for that day and the next day, there will be a survey that's open to you. And it says it's worth 0 points, but it's 3 points of extra credit. If I put it in as points, then Canvas screws your grade calculation up. So it's listed as 0 points. So you're going to get a lot of extra credit here, opportunities. All you do after you turn in your homework, go immediately to that survey. This is how long I worked on it. So I was able to get feedback from that. And I'm hearing, you know, the first homework should be a 2-hour job. And the first homework was pretty much a 2-hour job, but some people were like 4 hours or 6 hours. Well, the same thing here. When I do this effort estimate, like I'm saying P4 should be about 8 hours of coding. P5 should be about 10 hours of coding. And I had some people that were like, no, I only needed 6. But then some people were, I needed 20, I needed 25. Here's my advice. If you find you are spending a lot more time than what's estimated for these things, stop coding. Ask for help. I'm here. We've got 3 very good lab TAs. I'm here. You can ask for help. I was reading my reviews from last semester, and one student said, oh, there's way too much work for this class. At the last, you know, towards the end of the semester, I spent 17 hours on a lab. And I thought, man, that is unfortunate. And boy, that is a lot more work than this class should have. But on the other hand, I'm thinking, you know, for you guys, labs are 2 hours. If you're spending 3 hours on a lab, you should start to get a little bit, okay, you know, you're going to be frustrated, but I can see that that can happen sometimes. You know, sometimes it's hard to find a bug in a piece of code or something like that. Once you get to 4 hours, stop. I'm begging you, stop. Don't put yourself through that misery. There's no reason to. Ask for help. Go to the Discord channel. Ask the TAs. Ask me. I put up a discussion board where you guys can ask questions of each other. By all means, share snippets of code there if you want. This code doesn't work. I don't know why. It's really tough to get students to ask for help sometimes. So I'm encouraging you. If you asked for help, I see that as, it really makes me happy. It makes me happy because I'm seeing that you're not willing to waste all your time trying to figure out something yourself. When quite frankly, usually when people ask for help, we can resolve it fairly quickly. A lot of times it's a fairly simple fix. And when it's not a simple fix, the direction in which to go change things is clear. And it can take, we can do it through email exchange, message exchange, you know, Zoom meetings, whatever. So I'm encouraging you, ask for help. I'm also going to basically require that you show unfinished work to people, which horrifies students for the most part. You know, but I want you to get used to this idea. It's really important in engineering circles. It's really important to show unfinished work for people and ask them for feedback early on before you go through this long process, create a product, and then everybody says that product is no good. Ask for feedback. I'll give you an example. We are looking at the curricula. I'm in a committee that are looking at the curricula for the different programs that the EECS department offers. And we've worked over the last couple of months and we've made some proposed changes. And we're not going to propose these changes for real until the end of this semester. First meeting in January, when we met with our department faculty, we said, look, we've been looking at this and here's some proposed changes. Here's, you know, I think we had like 15 proposed changes. And for most of them, the rest of the faculty was like, oh, that's okay. But there were 2 of them where the faculty said, no way, you guys are wrong, wrong, wrong. Well, that's good for us to know. We took those changes off the table in our next meeting. That's good for us to know. Now, had we gone through the whole process where maybe some of our future decisions depended on those decisions that people didn't like, that would have caused a lot more trouble. So I'm encouraging you, show your work to myself, to other people. One of the things I'm going to do now that I think that our population is stable is I'm going to break you guys up into groups on Canvas. And then for, you'll see these, and I'll talk more about this as we get there. You see this 3.1? P3 is your actual deliverable. 3.1 is where you share that deliverable in a discussion page with people and they give you feedback, and it's groups of 3. So you're going to have to share and look over 2 other people's work, and they're going to share and look over 2 other people's work. And that's worth 20 points. So it's easy money if you participate in it. And the idea here again is you're going to show a draft document, show your work before it's done, and other people get to look at it and improve it. Don't think of it as criticism, think of it as improvement. Don't think of them as insulting you or trying to knock you down. They are improving your product. And that's a mindset that engineers need to have. And quite frankly, if students have that, if you get that mindset early, then it's really helps your product, which helps your grade, helps your GPA, helps your job prospects and salary. Okay, that's a lot about just the basics of the project. Do we have questions yet? Does it look intimidating, too easy, or somewhere in the middle? You're going to find out
somewhere in the middle for me.
You're waiting to actually see how it works, right? You're waiting to see.
Yeah.
I'll give you a lot of guidance. I'm going to give you templates for the reports. We're going to have discussions every Friday about this. No, the way that works. So homework 1 is due on Monday. Someone asked if the survey for homework 1 is out. No, homework 1 is due on Monday. And so that survey will be open for Monday and Tuesday. And we'll actually have to see how Canvas did that. I believe I made it available all day Monday and all day Tuesday. And if it's not, you guys need to let me know so I can fix that. Yeah. A little intimidating. Yeah, that's okay. And I want you guys to try to stretch yourself a little bit. Don't, pick a project, number 1, that you're really interested in, and then pick a project that's going to be a little difficult, right? I'm going to use the sheepdog game throughout as example. And I believe this semester, let's see if I can get this done. I can fill out all the products with you and show you examples with the sheepdog game, what these products would look like. Sometimes time doesn't work that way. So you'll have examples of how all this stuff goes together. And the sheepdog game, yeah, it's a pretty simple project, but it meets all the requirements. It's got GUI. It's got inheritance. I can do file IO with once I put scores on it, and I can do exception handling when I ask people what their name is for the score. So it meets the requirements. I really like this class because of the projects. You guys get really interesting project ideas, and I get to see a lot of creativity sometimes. So that's a fun part of the job for me. Oh, tower defense games seem to be popular now too. And a few semesters ago, I only got 2, and now I get like 5 every semester. Okay. Let me go to deliverable 1, since that's worth points before I go to topic. So I'm going to go out of sequence a little bit. Here's the assignment. It just describes what you have to do, and it's worth 20 points. And I'm estimating 4 hours. The reason I'm estimating 4 hours is not because it's going to take you 4 hours to write this thing up. It's going to take much less, but I want you to think about it a little bit. Oh, I'm sorry. Let me go back one time. And the reason, notice I'm put 12 hours here for P2 and P3. Now you have like 2 weeks to do it, or 2.5 weeks to do it. So you can spread that time out. But the reason I'm saying 12 hours is if you're going to do the job properly, it should take some time. So I'm encouraging you to spend 12 hours. Unfortunately, I think that's where most people short themselves a little bit. So I'll have people that worked on it for 4 hours or 6 hours. Guess who's spending all their time writing code later in the semester? So instead of having 10 hours on P5, they're spending 20 hours on P5 because they didn't put the early work in to do the design properly. So that's why I'm encouraging you to spend some time there. Anyway, here's the proposal. This is fairly straightforward stuff. The more important thing is I give you this form. This is back in the day when it was printed out, so I didn't change it. It has name. I'm going to know your name, but still put it on there. I'm going to know your name because of, when you submit it via Canvas. Overall description of the project, give me a paragraph or so, and then tell me how you're going to do the GUI. So for the sheepdog game, for the GUI, I would say the game field of play is presented to the user through the GUI, and the user will use some mechanism. I don't have to tie myself down yet. Joystick and/or keypad to move the dog, and the movement will be shown on the GUI. And then file IO, I would say I'm going to save and recall high scores. And exception handling, I would say I'm going to ask for the user's name, and I'm going to verify that they gave me a proper name, a proper string, that they didn't give me numeric data or something like that. And then for inheritance, I'm going to say I have a generic animal that will be extended to a sheepdog and extended to a sheep. So I can fill out those forms. The file IO and exception handling tends to be at this point somewhat generic, and I'm okay with that. We haven't talked that much about it, and you haven't designed your game yet. For GUI, if you just said the software will be shown on the GUI, that's not enough, right? Because I don't know why or how. Give me an idea of the user interaction. Oh, okay. So in the sheepdog game, the user interaction is the user is going to use joystick and/or keypads to move the dog and watch how the sheep respond. Up here, and I do have a little bit of verbiage in, is it in here? Yeah. For example, the program should be a platformer game. Not enough information. Number one, I don't know what a platformer game is. You have to assume that. You're using jargon, and if you're using jargon, you have to explain your jargon. So that's why I'm saying put a little bit in there. It doesn't have to be much. Project will be a platformer game. Platformer is a generic classic, is a category of games where a character jumps from platform to platform on the screen to escape an enemy or try to find an exit. Platforms may be stationary or mobile. The progress of the player is going to be modified by obstacles and enemy agents, or, some kind of opposition, right? It can be, you don't have to have all the details yet, but give a description of what this thing can and cannot do. Typing test. Oh, we have a typing test, and the user can test for speed and/or accuracy, and there'll be different categories of tests. For example, text that's presented all at once, text that's presented a line at a time on a crawler, text that's presented one line at a time, one word at a time, so that once you type that word, the next word shows up. And then the program will measure the difference in speed and correctness for those different presentations. I don't know, I'm making stuff up here, but you get the idea that you can put down an overall idea of what this thing can and cannot do. And you notice it's not a very big box, right? So, not too hard to fill it up. If you say, I'm going to make a program based on, I don't know, Zelda, I'm old, the old program, based on Assassin's Creed. Okay, that's not enough because nobody knows what Assassin's Creed is, right? You have to assume the reader doesn't know. Okay. Questions about this document? Okay, now let's talk about topics. Again, as I said, a lot of people, boy, they like this topic. They like games. That's very popular, and I don't have a problem with that. Games actually make a nice project, a nice class-sized project, meaning you can fit it in your semester. But I'm more of a simulation person and a trying to get results person, trying to do analysis person. So I like things like elevator study and traffic study. These are difficult. So if you do the elevator study, I've had two people attempt it last semester, and one person was starting to get close to what they need. But I would say if you're not very comfortable with statistics, you might want to, or you might not want to do elevator study. You know, but if you want to, I'm here to help you. I can point you out to different references. Not too hard, actually, not too difficult once you understand what you need as inputs and outputs. But the problem is a lot of students in their junior, sophomore year, you know, they haven't had statistics yet. They haven't had a class on how to do simulations yet. So we have, you know, you have to pick that up on your own. Traffic studies, a similar thing. I had some students do reasonable traffic study. Last semester, somebody did a simulation of an intersection, and then they could play around, I think, with the timing of the lights. And, you know, I was encouraging them where could you play around with the addition of a turning lane? You know, how would that affect the traffic if you added a turning lane? And they did a fair job, but they didn't really get what I was getting at. You know, they wanted to watch the cars go, and no, you don't want to watch the cars go. You want to run a million simulations and do the statistics, and nobody wants to watch that. Queuing model is a generic form of that thing. Fuzzy cognitive map is a math model of how different systems interact with each other. And again, if someone chooses that, by all means, I'm happy to give you some literature on that stuff. And I've had a couple good particle physics simulators over the years. Those are kind of interesting. You turn on electromagnetic forces, turn them on and off, you know, that kind of thing, or change the charge on particles and watch how things interact. Opera problem or other agent-based models. The opera problem is if you have a bunch of people in a room, how can they get out quickly? And I actually had a couple of really good agent-based simulations over the years. I had an opera problem one where you change the shape of the room. This is a real thing. Architects are designing buildings now, so if there's an emergency, can the shape of the building help people get out when they're in a panic? Or does the shape of the building hinder these people from getting out when they're in a panic and more people die? So that was one. And someone a couple of years ago did a great one where they had a village, and the village was broken up into hunters, gatherers, and defenders or something like that. And then the trick was, of this population, you had to adaptively keep experimenting and see what the right number of hunters were, the right number of gatherers were, the right number of homekeeper defenders were in order for the entire village to survive. And it was actually a machine learning model that they did where it ran its own simulation thousands of times and then came up with the right mix of these villagers in order for the village to have the most robust survival rate. So it's kind of a cool, I like that one. Also, last semester, I got in touch with Dr. Dowdy in Human Factors, and he suggested these topics. And I had two people do them last semester, one of which actually they created a product for Human Factors Department that can be used now. So if you work with them, you can get up to 30 points of extra credit. And I'll extend that to other faculty. If you find in your domain that you have faculty and they need like a visualization tool for class, like maybe you guys in AE, maybe your professors want a particular turbine engine graphics tool where they can change settings on it, you know, or different forms of engines. There's your inheritance, by the way. You know, that kind of thing. If you can find a faculty to sponsor you, and then at the end of the semester, I need a note from them that says, okay, I think they did a really good job or an average job, or, you know, oh, it's lousy, but they tried, you know, that kind of thing. Then I can assign up to 30 points extra credit. Okay, we're at time, but do you have questions real quick before we go?
I have a few questions about Lab 1.
Oh, can we put those in a Canvas message?
Sure.
Okay.
All right.
And if it's a good one, I'll anonymize it and post it too. And by the way, send it to Robert Apelian, not to me.
Okay.
He's the lab guy. Okay.
Professor.
All right, thanks.
Yep.
Will we be able to schedule meetings with you to discuss like potential topics for?
Yes, and I have office
project?
hours every Wednesday from 3 to 5, but you can also message me on Canvas, and if we have to meet, then we can schedule meetings, yes. And I find those to be very helpful.
Okay, thank you.
Mm-hmm. Okay, guys, I don't want to keep you. Thanks for being here. Have a good weekend.
Thanks. See ya.
Thank you
Bye.
so much. Have a wonderful week.